Hello and welcome to Building Happy Little APIs, a deep dive into APIs on AWS. I'm Eric Johnson. I'm the Senior Developer Advocate for Serverless Applications at AWS. And Alan, tell them who you are.
My name is Alan. I'm a Senior Product Manager with Amazon API Gateway.
All right, excellent. So what we're going to be talking about today is building APIs on AWS. And this starts a 13 episode series where we'll be walking through live code and examples. In fact, we'll give you kind of a what to expect. We're going to be doing deep dive into features and services of API Gateway and how you do APIs on AWS. Live code examples, live Q&A with API Gateway experts, and there's 13 episodes. And so the idea here is we want to give you the nuts and bolts of APIs on AWS and how kind of the gotchas and kind of the how to work through that, because really honestly, if you think about it, building APIs should be a peaceful, calming experience. That's why we call them happy little APIs. I can use this voice, but you may not hear me. So as we get started here, these are the episodes, and I'll kind of let you look at this for a moment. We're going to be talking again. We're going to be doing live code on the ins and outs on security. We're going to be talking about and I'm just going to use the same finger. You guys will see just the same finger over and over because that's all I got. And so we're going to be doing the REST APIs. We're going to be looking no mom, no compute, which means working without lambdas. We're going to be talking about web sockets and how we support web sockets. We're going to be talking about containers and with Amazon API Gateway. So there's a huge gamut of things that we'll be covering. So I encourage you to come back to each episode, and each one will be encapsulated on its own, so it will give you a lot of information. So if you miss one, it's okay, but they'll build and work on top of each other. So we're going to start this session. And this one's called Building Happy Little APIs. I didn't know API Gateway did that. And the idea here is a lot of times when we talk to customers and we work with people who are dealing with APIs, they didn't even realize that API Gateway could do this, or have the idea that, hey, I can handle things like throttling or caching, and we'll talk about more at the API Gateway level. A lot of times we find people are rewriting or writing or inventing their own wheels, so to speak, wouldn't you say?
Yeah, definitely. And I think just by this first episode, it makes a lot of sense to just kick off the following episodes by giving a high overview of it, right?
Yeah. So that's what we're going to be doing, is a high overview on what features, what kind of services that we can offer. So without further ado, let's get started. So when we look at API, when we look at API Gateway, we look at APIs. We want to explain, what is an API anyway? And I'm going to turn this over to Alan because he's really our expert here, and let you explain it.
All right, thank you. So APIs, they're not a new concept. They're really, if you think about it, they're more like functional black boxes, right? Developers use APIs to do certain tasks, but they don't need to know exactly how it works. So if you think about, traditional programming where you're trying to even read and write a file, you don't need to know how the file system works. You don't need to know where the metadata is stored. You're just simply calling an API to read and write files. Similarly, when you started talking about web service APIs, the idea is very similar. Companies provide an API for you to do an action, on their remote servers. For example, social networks like Facebook, Twitter, LinkedIn, all of them offer APIs for you to build on top of, to send messages, add friends, right? Similarly, for payment processors, Amazon Pay, PayPal, Stripe, all of these have APIs as well. So you don't need to actually know what are the fee structures for Visa or MasterCard. All you have to do is send your customers to those sites, and then you get a response for basically whether or not payment was cleared.
Okay.
So that explains, what API is. And let me ask you, Eric, how do you think APIs and API gateways work? Tell me a bit about API Gateway.
About API Gateway. So when we talk about API Gateway, and when we talk about how APIs work, on Amazon specifically, or on AWS, we provide the Amazon API Gateway, and at AWS, what we feel like is APIs are kind of a heavy lifting idea that customers shouldn't have to worry about. We want to kind of abstract that out because we want them to be able to concentrate on what they do best, their codes and things like that. So what we did is we introduced API Gateway, which is a fully managed service that makes it easier for developers to create, publish, maintain, monitor, and secure APIs at really any scale. And you have a lot of control and power over that. So if you look at API Gateway, and this is kind of an overall architecture on what an API could look like, and these are quotes just so you know. And so what this would look like is, our API gateway can provide private endpoints. It can provide private integrations. There's caching. There's security through WAF. There's all kinds of different options, and you've got to think of API gateway as kind of two different ends: the front end and the back end. And the front end can come in through several different places, and we'll kind of break those down in a minute. Just from all kinds of angles, and the back end can be routed to another set of angles. So there's a lot of flexibility that's provided through the API gateway, and that's just what it is. It's a gateway. It says, look, I'm going to take you want to come in, and I'm going to help you route to where you need to go. So there's a lot of power that goes on there. So why don't you break it down? If you think about the types of API that we offer through API gateway, can you walk through those?
Yeah. Let's take a look at the center part of that diagram that you just had, right? So API Gateway offers three types of APIs. Edge optimized APIs. These are really great for when you have a globally distributed set of customers, right? Because what we do is we actually put a fully managed CloudFront, which is a content distribution network, in front of the API. So when your clients make a call, they get a response a little bit quicker. And then we have regional APIs. These are APIs that, they're really designed for general use cases. They're great for when you're building APIs for when you're calling out to a service that's in the same region, or if your clients are in the same region, or even when you want to manage your own CDN in front of it. So whether that's like CloudFront, you want to manage some of the configurations a bit more manually, right? Regional APIs are great for that. And finally, we have private APIs. These APIs are only accessible from within a virtual private cloud. That's really a tough one. Yeah,
it gets me.
And they're designed for when you're building internal use APIs. So, for example, between different development teams within the same company, or within microservices that are just within the same VPC.
Excellent. Okay. And I'm going to take a break here and let our viewers know that if you have questions, please type them in. Please enter them, and we'll do our best to answer the questions that we can. If I can't answer it, Alan probably can. If he can't answer it, I will answer it. So, but between the two of us, this is something that we love and do, and so I encourage you to ask us questions. This is also being recorded, so it can be watched later. So we've talked about the kind of APIs that are available. You have edge optimized, you have private, you have regional. So that's kind of the how you approach the API gateway. What about the protocols? What would you talk about the different kind of protocols that we have?
Yeah, so we support two types of protocols, REST on top of HTTP. This is your very basic request response type calls. You make them using HTTP methods like GET, POST. Then they're really just short-lived connections for the purpose of that request and response. And they're stateless. So this is the type of API we've had for a long time. And more recently, at the previous re:Invent, we actually introduced WebSocket APIs. And what's really cool about this is that this is a serverless WebSocket. So between your client API gateway, this is going to be a long-lived communication over the WebSocket protocol. It's stateful, and it enables two-way communication, right? So if your clients can push messages to API gateway, and API gateway can push messages back to the client. So what's really beautiful about this now is that in the backend, from API gateway to your integration or to your backend, this can still function as it is today, using traditional HTTP. So all your existing HTTP backends and Lambda functions will work exactly as they do today, and you can use them to power these new types of applications on WebSocket.
All right, so two questions for you. First one, stateful, stateless. What does that mean?
So stateless means, between calls, you're not keeping any kind of information. So every call is basically independent of the next.
Okay.
For stateful, there's some state being stored. So for example, if you're sending a message or you're doing where one is dependent on the next thing, you can do that.
Okay, so when you're looking at WebSockets and you say stateful, would that be like the information maybe be the identity of the client, so we know who's talking back and forth?
Yeah.
Okay, alrighty. Okay, so the second question I had when we're talking about on building these, boy, I got confused there. What kind of, when you look at the concepts of API, can you kind of talk through, all right, so we're talking about the different, you have request and response, you have WebSockets, things like that. How does API Gateway break it down into the parts, and what are the concepts behind the API Gateway and how it handles this?
Yeah, so if you think about the components or the concepts we have in API Gateway for each of these API types, they're very similar. So for REST APIs, at the base level, there are resources. This is just a collection of configurations for your paths and methods. So for example, if you had like a user endpoint or user path and you want to list users, that would be a get on that user's path, right? And for when you're configuring, you can say, hey, I want this to have authentication or not. I want this to maybe just go directly to a DynamoDB because I don't really need any processing in front of it. And then maybe for posts to the user's path, this one, I want authentication and authorization, and I also want it to connect to a Lambda function.
Okay.
So each of these paths and methods you can have different configurations for, and that's really what resources are. And then a deployment then is a point-in-time snapshot of these configurations. And you can have multiple of these within one API. And you can think of them like a version of that configuration, right?
And that's specific to API Gateway then?
Yes.
Okay.
And even the resources, that's also specific to API Gateway. And then we have stages. This is a link to the deployment, and is really the concept that makes that deployment active and actually exposed to your customers and users.
Okay.
And you can also have multiple of these stages, and if you have multiple, you can actually use them to represent your development lifecycle. For example, one stage for alpha, one for beta, and one for gamma or dev test prod, whatever your naming convention is in that case.
Okay.
So looking at WebSocket, the concepts are very similar, right? We also have routes, which is basically just a combination of paths and methods. You can very similarly define for each route if it has authorization or if it's going to a Lambda function or a different AWS service, right?
Okay.
And deployments and stages work exactly the same.
Are the same. Okay. So that breaks down the concepts of that. Okay. So one of the cool things that about API Gateway and kind of how AWS works in management anyways is how you manage your services. And API Gateway specifically has 5 ways of managing it. It's really cool. First of all, you can do the AWS console. Using the AWS console, obviously you can log in, you can configure your AWS or your API Gateway. You can use the CLI. I love CLI. I think it's a fast way to go in and out. I'm not the fastest typer, but I enjoy doing that. You have AWS SAM, and if you're not familiar with SAM, SAM is our serverless application model, and it's kind of an abstract of CloudFormation. So you use a lot of the same languages and formats. It's in YAML or JSON, where you can do your resources and list them out. And API Gateway is one of them. In fact, you can even import into SAM like a Swagger file or something like that if you have a more complex. I'm right in that, right?
Yep.
Okay, cool. CloudFormation, obviously, you can do the more verbose version of CloudFormation where you can list out your API Gateway. And finally, and this is really cool, is OpenAPI or Swagger. And so what this gives you the ability to do is you can, if you have an OpenAPI template, you can import it into API Gateway and build it that way. And we'll talk more about the power of that a little later, but there's a lot of strength there in being able to deal with or to work and manage your API Gateway in multiple ways. So one of the things that, as a developer advocate is we go out and we speak to people all the time in conferences and things like that, and we talk to them about services and how they work, and it's always surprising to me when someone will ask about API Gateway, or not even API Gateway, but how do I accomplish such a task? Like, how do I secure my application? What's the easiest way to do that? And sometimes we come back and go, wow, you can use an authorizer on API Gateway, or you can use throttling or something like that. They're shocked. It's like, I didn't know API Gateway could do that. And so that's one of the reasons that we decided to put together the show, because I think there's information that can be shared on, wow, that'd make life a lot easier. So for the next probably about 45 minutes, we're going to drop into some of the features that API Gateway offers. This is not an entirely exhaustive list, but it should dive in pretty deep, and we'll see if we can stump each other. So we'll get started here. So Alan, I'm going to let you start out with, at AWS, first and foremost, security is top priority for us.
Yeah, that's right.
So we're going to talk about that first. So I'm going to let you kind of walk through the authorization if you could.
Yeah, so API Gateway provides basically 4 methods of authorization, right? The first one is, completely open, no authorization. I suppose that's a type
Okay,
of authorization.
It's an anti-pattern.
Yes.
So, okay.
So it's really good, for example, if you're just building public APIs that you want to expose publicly for other general developers to use. Otherwise, we have 3 ways to actually do authorization. One is using IAM permissions. So you can define IAM policies and then on the API, and so then you can sig before sign that request, and we'll actually check if that user has access to those to the resources defined in that policy.
All right, I'm gonna stop you there.
Sure.
What was that sign? How do you sign it?
So you have to do sig before signing. There are a couple of methods to do that, maybe 3 actually.
Okay.
So one, the easiest one probably, is just to use the SDK that's generated by API Gateway. So once you've fully fleshed out your API, once you've fully defined it, you can actually use API Gateway to create an SDK for your clients.
Okay.
And then that client will actually do the signing for you. Alternatively, you can pull any one of the open source libraries that does sig before signing.
Okay.
And the last one, probably the one that takes most effort, is that you just read our documentation on sig before and you write the code to do it yourself.
So how often would you suggest that route?
Probably very, very less often.
Yeah, that's right. Yeah, I really encourage, kind of a rule of thumb for me, so to speak, is if the SDK is already being generated, use that. Or use one of the libraries. Writing your own doesn't make sense anymore. So I really encourage people to start with the SDK. If that doesn't work out, then to use some of the sig v4 libraries. And I've seen them, Node or Go or different languages have different ways of approaching that.
Yeah.
So, okay, so Cognito Authorizer.
Yeah, next to Cognito Authorizer, Cognito is the managed user directory service in AWS. So what that means is you can manage usernames, passwords. You can reset their passwords. You can create groups of them and group users into groups. And you can also do sort of like the 2-factor auth requirements. So all the great stuff you would expect from a user directory service, right? So if you have Cognito Authorizer, what that does is it connects it to a Cognito user pool, and together with OAuth scopes, it will enable authorization on your APIs.
Okay. All right, so we threw a lot of terms out there. So let's talk about this for a second. So first of all, and I'm going to jump into the Cognito. So if I'm going to use Cognito user pools, and Cognito is a separate AWS service, I can go out in the console, the CLI or SAM or CloudFormation, and I can create a user pool, and I can create, and in that user pool, I can even do groups, right? I can do like admins.
Yeah.
Okay.
Yes.
And then at that point, I can, and Cognito will actually generate forms I can use to log people in if I wanted to.
Yes, hosted UI. That's
okay,
right.
all right. So through hosted UI, or I could use something like Amplify, which would pull those into my application.
Yes.
Okay, so
and you can actually use Amplify to set up all these authorization as well. If you're building your API with using the Amplify framework,
that's a good
it'll
call.
give you security options, and you can define those directly in that Amplify CLI.
All right, so then that would give me my UI. Then I can use the parent or the tags to build my UI. So then I create a user. I can validate the user, all those kinds of things. Okay, using MFA. All right, so at that point, how does API Gateway tie into that?
So I think this might get a little bit more involved than we have time for.
All right, that's fine.
But basically, when you're configuring a Cognito user pool, you can say what scopes are returned, and then in API Gateway, you can basically just check against those scopes.
Okay. Gotcha.
But yeah, that's a very high-level description of that. But basically, yeah.
So there's a token that's passed from the client that the Cognito Authorizer would see.
Yes, and then we'll just crack open that token.
Gotcha.
Yes.
All right. Excellent. Okay. Sorry, Lambda Authorizer. I'll be quiet for a minute.
So Lambda Authorizer, this is going to be your maximum flexibility authorizer. You can basically do anything you want, right? You can validate a bearer token that's coming in, or you can just take a look at the request parameters that's in the payload that's coming in, and you can create and generate policies based on that to actually grant access and authorize requests.
Okay. So I could tie that to like a camera, and only if you have a red shirt on, you could come in.
Yeah, if you really want to create that authorization model, then
yeah. Or thumbs.
Yes.
Okay. All right.
Actually, one thing I forgot to mention is that for both Cognito Authorizer and Lambda Authorizer, you can actually use it to validate tokens from a different user directory as well. So for example, if using Auth0 or Okta, you can do a federated relationship with Cognito and check and validate those tokens. Or if you're just using Lambda, you can crack open those tokens and verify them yourself.
Okay. Could I use like Facebook?
Yeah,
Something
yeah,
like that?
yeah.
Okay.
So Kaggle also supports OpenID Connect.
Okay. All right. So a lot of flexibility there.
Yes.
Okay. Very cool. All right. So let's move on to our next feature, and I want to see if there's any questions coming in. See if we have any there. We're going to be checking for questions while we go on. So when we go on to the next feature, I'm going to talk about a little bit, kind of almost a bread and butter of at least the REST version of an API gateway, or both actually, is the request and response. In API gateway, it's a lot more than here's the request, here's the response, that's it. We just shake and move on. You have a lot of power that you can do before you even hit your integration on the backside, and I'll talk about that. So when a client, and it could be a website, it could be a mobile phone, it could be a service, it could be really any number of things, but a client makes a request to API gateway. What it's going to do is the first thing it's going to go through is what's called a method request. And in this area, we can do data modeling. We can do validation of data. We can also do transformations. And so if you think of this idea of, let's say we have a service that I don't know, uses XML or something like that, and our clients send a specific request. We want to change that service, but we can't change our clients. So we need to modify that request when it comes in. So at the method request level, we can modify our request and then pass it to the integration in the new format. And when I say integration, I mean we've listed some examples here. We can integrate directly with Amazon S3, directly with Amazon DynamoDB, with AWS Lambda, and other AWS and even on-premise services. And this is kind of cool because a lot of times we think, well, if we're going to use API Gateway, it can only sit in front of a Lambda, right? Yeah. I think that's kind of a misnomer. I can, in fact, I've built an application where I made a request into API Gateway. It transformed that into the proper request against DynamoDB. I got my response, and there I didn't even need Lambda at the time. Now, obviously, Lambda works great when we need that compute power, but the integration is not just to Lambda; it's really to almost any service behind there. So after the service does whatever, so let's say we are integrating with DynamoDB. After DynamoDB does the query and gives us a response back, at this point there's a couple things we can do. One, we can transform it into a format that our client is going to expect, and that's a powerful tool because so I'm not having to call all my clients or send emails or snail mail or something saying, hey, we're changing the way our stuff works. Instead, we're just going to change it when we send it back, so it's transparent to your users. And this is often a pattern that people use when they're moving to new services, where they'll take what's called the strangler pattern.
Whoa, Eric. Strangler pattern sounds really scary, like something from a horror movie.
It is.
Can you tell me a bit more about that?
So yeah, the strangler. That's funny. The strangler pattern. What the idea there is if I've got a service that's an old service and I want to start pulling that off, I can wrap API Gateway around this service. Okay, so my clients they don't even know.
Got it. Makes
so it's
sense.
Nothing deadly, nothing crazy like
Okay.
that. Okay, yeah. And so what happens is, as I pull off individual services, I can reroute those through API Gateway. And again, the client is unaware. So until the old service is gone.
Got it. So it provides a level of abstraction, right?
That's right.
Okay, makes sense.
Okay, alrighty. So it's the other thing we can do are custom errors. And so when we have, maybe the integration response is something that we don't like, we can customize that error and we can feed it back to how our clients expect it. So just in the simple request and response model, there's a lot of power that can be done. And in the language for transformation, we use the velocity templating language. Which is from Apache, and so it's more than just hey, you can use some logic in there, you can use parameters, variables, different things like that. So there's a lot of power there. So one of the other things, Alan, that we talk about in using API Gateway or any time, one of the things is how can we make it faster? How can we make it more responsive? And one of the ways that API Gateway helps do that is through caching.
Yeah, definitely.
So I was going to have you, if you can, kind of explain how caching works on API Gateway.
Yeah, so caching is just a general computing concept, right? Basically, you're storing some bits of either computed data or a copy of data that's somewhere else. Maybe it's further away, so it takes a while to fetch that in a really fast memory store, typically in memory.
Okay.
So the next time someone makes the same request, we're able to just respond with the data directly from the cache, and we don't actually have to do the computation or do that network transfer, right? So it's going to be really good for providing quick responses back to your client, and for actually minimizing load on your backend, because now you don't need to do these unnecessary fetches or compute, right? So how the caching in API Gateway works is that for a given request, whether that's based on, and we can create keys based on these requests, whether that's on path parameters, headers, or query strings, we're gonna cache the response coming back from the backend or from the integration. So the next time a different client asks us, based on the same path, header, or query string, basically the cache key, we'll just provide that response back directly. And the caching can be actually set up at the per stage or at the method level. Okay. So you can actually have a lot of control over, what methods you want cached and where you want them cached. So it's not just like a very generic cache.
Gotcha. Okay, so break this down for a simple guy like me. All right. So talk scenarios. So let's say I've got a URL. It's mydomain.com/fruit/banana.
Okay.
So my parameters are fruit and banana. So they're going to be what fruit I want, or product. Let's say product is fruit and the type of product is banana. Okay. So if I cache on those two strings, so you do a request and get banana, and it goes out, and make sure I understand this, it goes out and pulls that data off the database and then caches that and responds to you.
Yes.
Okay. I do the same query string, same exact one. Do I get it from the database, or do I get it from the cache?
You get it from the cache.
Okay.
Because we've set cache keys on both the produce or the product and the fruit, basically.
All right. So what if I add an extra parameter that says ripe yes or ripe false? So it's a ripe parameter, but that's not part of the cache key.
Then it'll just return with the response for the banana, right?
Okay.
Whether or not it's how ripe it is. So, so as you start making things more specific and refining your cache keys, you should definitely make sure to update that and keep that updated.
Okay, so there's a very clear strategy on cache keys.
Yes.
Okay, all right, so I want to make sure that we work through that. Okay, that makes sense. Is there any time, when you're doing cache, is there any time, how do I invalidate that cache? So I want to update my code. How do I get rid of all that?
Yeah, there are a couple of methods. One, the very straightforward one is that you just call the flush cache API that we have.
Okay.
You can visit our documentation to see what that exact call is. The other one is we actually let the clients actually send a cache invalidation parameter that will actually say, hey, I just want to skip the cache this time and refresh the cache for this specific cache key. And obviously we also put authorization in front of that, so you can also control who can make that invalidation as well.
Okay, very cool. So that a lot of speed is added there. Latency.
That's right.
Okay, very cool. Does that count? And maybe this is stump one. Does that count when you're making the call? So that wouldn't count against like a lambda. Obviously, I'm not invoking the lambda.
Right. That's right.
So that reduces
Exactly.
costs as well.
Yes. Okay. Because API Gateway would respond. The lambda function wouldn't see it.
Okay. Got it. Excellent. All right. So the next thing, I'm gonna let you do this as well.
Okay.
Again, we're still kind of on the same idea of speed, but also when people build a API game, people build applications in general, and it's funny when working as I was a solutions architect for a long time, and everybody's got the next big thing, right?
Yeah.
So and I can't tell you how many rooms I've sat in where they come in and go, look, we've got an application idea, and we're gonna need to be able to handle 1 million requests per second, probably in the next week, maybe. I don't know. We'll see. And it's hard to keep a straight face, but that's the truth. We've all got the next big ideas, and some of those are, right? But in order to kind of maintain, in order to have an effective strategy of throttling, walk through that on API Gateway and how that works.
Yeah, so API Gateway offers throttling. So what throttling is actually you're basically saying, only accept requests at a certain rate. So, whether that's like 1 request per second or 1 million requests per second, right? Just putting that limit barrier there. And API Gateway basically provides 4 levels of this, from very fine-grained to per client per method, which is what you see on the left, to very coarse-grained at the per account level. So how throttling works in API Gateway is that a certain request has to actually pass the request limit for all these 4 levels before it'll go through to your backend. So what that means, for example, is then if I set my per account limit really low, let's say 1 request per second, and I set my per client per method one to 1,000,000, that client is effectively just going to see 1 request per second.
Okay.
And there are some slight differences between the 4 levels, right? The leftmost two, the per client ones, those require you to set up a usage plan and an API key, and then you basically give each of your clients an API key, and those API keys are then subjected to the throttling limits you set in the usage plan.
Okay. So an API key, like if I have a company that's hitting my service, I would give them this. Okay, always hit it with this API key passed in the header.
Yes.
Okay.
That's right.
Okay. And can usage plan? What exactly is a usage plan?
Usage plan is basically either like a product group or like a usage tier, if you will.
Okay.
So you can think of it like a way for you to set fine-grained throttling at that usage plan level, and then what you do is you associate API keys to the usage plan, in which case all the API keys then have that limit applied to it.
All right, so multiple keys can go to one.
That's right.
Okay, so I may say, hey, I've got any partners of mine are on this key.
Yeah,
okay.
that's right.
And they're all on this users plan. Okay,
yes.
I follow.
Cool.
Okay.
And then the ones on the right, the per method and per account, they actually apply across API keys and across clients. So they're more like a I don't know, like a broader, total bucket, like a broader application of throttling.
Okay, so in that, so help me understand this, because throttling can be confusing sometimes in general. Not in general. Just in general. Per account, does that override per client per method?
I wouldn't call it override. You just have to pass through all the layers.
Okay.
So like, for example, if you set it really high, you're not over like maybe 1,000,000 requests per second at the per account. You're not really overriding the limits you have set at the per method, per client, and the per client per method, right? You're really just widening that specific layer because, as I mentioned, all the request has to basically pass through all 4 layers.
Okay, so it's an and.
Yeah, or like you can think of it like a min of all 4, right?
Okay, gotcha. All right, minimum for non-developers. Yeah. So yeah, exactly. So all right, so if I'm building a throttling strategy, where do I start?
I should probably start thinking about it from the per account level, right? Because that's going to be, at the end of the day, the one that limits all the requests since it has to pass through all 4, and then basically work towards more finer granularity as you need it. Okay. Right. You don't want
right to left in
right to left in the diagram. Okay. That's right.
And but it's evaluated left to right.
Yes.
What's going through?
That's right.
Okay. Alrighty. Okay. Very cool. So with throttling, so what that allows me to do then is, let's say, I do build the next best thing. Okay. And they're pictures of me and my dog skiing, I guess, or something like that. And everybody wants a picture of this, which is very common. I'm pretty sure it's going to happen. And so what I could do is say, look, I just need to minimize this at, let's say 1,000 per second or something like that, because I don't, maybe I don't want to pay, first of all, because we know API Gateway can scale.
Yes.
So sometimes this isn't. We think you're going to take API Gateway down. We think it's you're
going to take your server down.
Exactly. Yeah. You need your server behind it. Exactly. So alrighty, and then there's obviously a cost factor in there as well.
That's
in helping to reduce. So we're not just wide open. Hey, anybody can hit it. Whatever. Okay. All right. Very cool. So. The next thing I want to talk about, and this is kind of interesting, when we talk about routing things through. Did you have something to say? You look like it's...
No, go ahead.
All right, yeah. When we talk about routing through our requests and how they come through your API gateway, one of the things that we offer is a private integration. Now, it's important to understand that private integration is not the same as a private API, which threw me at first. I was like, oh, okay, I figured this out. So the idea, if we go back to this idea of 2 sides to API Gateway. There's how things enter it, and then how it's routed on the back side. And so on a private integration, what we're able to do is, using a network load balancer, what we're able to do is connect via VPC link to that load balancer, and we can make available things that are in a VPC. You can make them available to really anything via the API Gateway. So for example, if we're setting up an architecture and as a solutions architect and sitting down with customers, one of the things we always tell them is put everything in a VPC. at least from your EC2 instances, things like that. Put them in a VPC. That's that's one of the primary levels of protection. So we talk about the onion and layers moving in. So we encourage people to put things in there. But if we want to expose it, now one way we might do it is just through a load balancer. Okay, so you can hit a load balancer from external, and then it can go through to one of your things. But if we need an API management technology, you can do the same thing by connecting your API gateway. So then what you do is you get all the power of your authorization through Lambda authorizers or Cognito authorizers or IAM permissions, WAF and different things that we'll talk about in accessing private integration or integrations or in a private VPC. The other cool thing is through AWS Direct Connect, you can also hit on-premise devices as well. So the power here is, again, it's the extra layers of security. When we talk about, accounts and security groups and availability, all the different things, and being able to put devices in a VPC is especially specific EC2 instances, things like that you spin up. Putting them inside a VPC is just good practice. It's part of the well-architected framework. So private integrations.
You touched on something really interesting that I forgot to mention before, which is that if you put API gateway in front of your private integration, in this case, so actually anything in your backend, what we see customers really like is that API gateway is basically acting as a central location for you to do all your throttling, all your authorization logics. So you don't have to do that in the back end, right?
Right.
So you have like a single unified authorization solution instead of building all of these repeatedly in your different backends.
Yeah, that's a good point. And we'll talk about it as we get in a little further. But things like SSL offloading, caching, authorization, where if I can do that centrally and not have to do it at each server or each service, that's a really good point.
Yeah.
Alrighty. So the next thing we're going to talk about is staging, and you touched on this earlier.
Yeah, it's a little bit.
Yeah. So the idea of staging, there's a couple ways you can look at this. We want to look at it first of all from just the API gateway window. I changed the slide up. Did you see that?
Yeah,
it's kind of cool.
It's a very nice slide.
I'm just saying. So the way you look at API gateway and stages is like Alan talked about earlier. A stage is a pointer to deployment. So I could have, in this particular scenario we're looking at, I have 3 deployments available. One is a dev, one is a beta, and one is a prod. Now these are deployments of the API gateway itself. Okay, not the application behind it, but the API gateway configuration itself. And that's an important distinction, because I think sometimes we talk about deployments, we think code. Or we think, our Lambdas or our, things like that. But API gateway, because it's kind of an infrastructure as code, that kind of it is, you have a deployment of API gateway as well. So you might have a resource and method configuration. You might have an authorization configuration and things like that. So this allows you to have different testing areas. So you can have your developers just, testing and development and going to town on this. You can have beta, where your business might be checking the latest version of what you're going to do, and then you have production, where that's what's actually out there. And you can move developments through these stages. You can also, as you see, we have this idea of called stage variables. So if you have different information that changes per stage, you can store that at the stage level, allowing you to say, hey, it's this connection string or this. In our example here, we're going to use a Lambda alias. And so if you kind of look at how this works in conjunction with Lambda, it looks like this. And what this does is in Lambda kind of has this idea of stages as well. We call them aliases. And I don't know if it's the same thing, but we have alias and versions in Lambda. And so you see here on the right where we have versions 1 through 9. And 9 is our latest bleeding edge. It works because we're good developers, right? So it's going to work. We could test in production, but the bosses said no. And so, but anyway, so what we do is we have development. That's our bleeding edge. And so our development stage in API Gateway has a variable called Lambda alias. And it says, hey, which Lambda alias should I point to? And we dev. So that allows that variable, that allows us to call the dev alias, which points to the latest version of our code in a Lambda. So there's a lot of power, a lot of flexibility. You also with beta, same thing. You line this up, your Lambda alias points at beta, so it calls the beta alias in a Lambda function. And finally, you have the product, which calls the Lambda alias of prod, and it calls prod and the aliases in Lambda. So here you have two kind of different things working together. Your API gateway stage, which is going to change your API gateway configuration, and your alias. So if you have to make changes in the back end, let's say you're making this scenario we talked about the other day, an authorization change, which that's a pretty big deal.
Yeah.
Because if I don't have to authorize, if I have something open up and all of a sudden I have to log in.
Yeah, you might lose some customers.
Exactly. So what I'm going to do is I'm going to put that authorization as an authorizer on the dev stage in the API gateway, and then I'm going to put any code in the back end that maybe I have to change and do something in the Lambda in the latest version. And then as those test, then I'll move them into beta so my business can test it, and then finally into production. And so this gives us a lot of control over how we can release. But even with the idea of staging, do you ever want to just push everything out at one time?
No, probably not, because
but my code is good.
Sometimes there are bugs, it's hard to tell.
I fat finger once in a while, so okay.
Yeah.
All right, so the next thing we want to talk about.
Let's talk about Canary Releases, which really ties into what your question, right?
Yeah.
So what Canary Release does is it actually lets you specify a percentage of requests that go to your next version from your current version. So let me break that down a bit. What I mean is that, let's say we're actually making that authorization change that you talked about, Eric, right? We're going to put authorization on top of, in our API, on top of our, production Lambda, if you will, or production stage. So when we're introducing this auth change, we actually want to minimize and make sure that as we're going from dev to prod, that there's, we're not losing any customers or they're not seeing any access forbidden errors, right?
Okay.
So how we can do that is by using Canary Release. So what we can do is we can say, this version in this diagram here, the prod version is the current version. Canary +1 is the version we're adding authorization on. So we can say, okay, I'm gonna set up my Canary release. On my Canary, I want maybe just 2% of the requests, right? Just start small to keep my blast radius small. So if it's a catastrophic change, then I'm only affecting 2% of the requests, right?
Yeah.
And then 98%, just continue into prod. And then I can actually just monitor my CloudWatch metrics or logs to make sure there are no issues. And then as I ramp up my confidence, I can start ramping up the percentage in the Canary. So from 2 to like 10, 20, 70, 80, 100. So once I'm done at 100, then basically the stage is just pointing to prod +1 and there's no more Canary because the Canary becomes the actual non-Canary prod version.
Okay, so it's not a one-time phase then. You can actually, so it's not like 10%, then 100%.
Yeah.
You can actually phase through.
Yeah, I can phase through. I can actually phase back as well. So if you're saying, this was really catastrophic, I'm going to make it 0% on my Canary.
Okay.
Yeah.
Alrighty. Good way to minimize the blast radius. I like that. Did you notice the skinny arrow on the left side and the fat arrow on the right? How I'm doing that traffic representation?
That was a really nice touch, Eric. I appreciate your PowerPoint skills.
Just wanted to pull that out. I was pretty proud of that. So, okay. So with Canary Releases then, obviously CloudWatch is critical. Anytime I'm monitoring, anytime things like that, so critical. And then you can move those over and Canary goes away. So a lot of protection in that.
That's right.
Okay. Alrighty. So the next thing I want to talk about, and this is something that's fairly new, or at least how it's implemented, is what we call a Web Application Firewall. Or WAF, and I'll probably call it WAF because Web Application Firewall ties up my tongue. I'm not that skilled. And so with a WAF, it used to be that we would go through CloudFront to do that, but reInvent last year, was it reInvent we announced this? That the direct integration.
Just a little bit before reInvent, just a tiny bit before.
So integration with the WAF directly into API Gateway. Now WAF is very interesting in that it provides a level of security that you can get custom, you can get crazy, you can get custom with your rules, and so the way it works is, let's say we have our two clients here. We've got our client with the orange and the red, and so what happens is the clients make the request against API Gateway. So our orange one, we validate their request. Maybe it's a token header, maybe it's an IP address, maybe it's a geographic location. There's different things that we can evaluate, and we pass that to AWS WAF. And the WAF evaluates it against the rules to see if it should be passed on or not. If it should, then what happens is he passes that integration right on through API Gateway to wherever destination it's supposed to go to. However, if it doesn't, then the connection is just dropped. It just, nope, you can't get by me. And this is really handy when you're working with things like, again, like a geographical. Hey, we want to minimize this just to US or EMEA or Asia or something like that. Or we want to just limit it to our office with an IP address. What are the scenarios do you see people using WAFs for?
I think that's the most common one, actually, limiting within an address range that your company owns, right? So you're able to sort of do this semi-private type API by using a WAF in front of it.
Okay, very cool. So again, a lot of power there, and behind it, because this is inside of API Gateway, again, it's this backside, front side idea. On the backside, we can route to really anywhere we need to route to. So a lot of control there. Now, we're in the earlier, when we were talking about Canary Releases and things like that, we talked about monitoring. We talked about CloudWatch.
Yeah.
Again, it's always interesting to me. Monitoring, logging, metrics, things like that always seem to be an afterthought. Have you ever noticed that?
Yeah, typically when people are designing application, they get working. It's a part of a POC, and then an issue occurs, and they're like, "Oh man, I wish I had logs or metrics for this." Right?
Exactly. Yeah. So we'll log when we write our tests. You know what I mean? That kind of seems to be the theory. So, but I think if the way at AWS and with the tools that we have, it really enables you to think metrics, think logging, those kind of things up front. Build it right into your applications. And API Gateway is no different. Do you want to walk through some of the things you can do with API Gateway?
Yeah. So API Gateway is well integrated with many of the monitoring, metrics, tracing type services offered by AWS, and that's because they're much better at doing those things than we are, because they're built for that purpose.
It's a core competency.
Yeah. So the first most basic is Amazon CloudWatch metrics integration. So out of the box, we provide 7 metrics, and you can optionally enable those metrics at the per API and per stage level, and actually per stage and per method level.
Okay.
So you can get some more granularity into at where in the API it's throwing these errors or generating these metrics. And next, we also have AWS X-Ray integration. So AWS X-Ray lets you trace a call going from client all the way back to the back end, and then back to the client. So you're actually able to visualize a map of the call going from your app, passing through API Gateway to maybe your Lambda function, and then going backwards. And at every single stage, you can see what the latency was at, and you can see what status was returned. So it's actually a really powerful tool for when you want to do tracing or profiling or performance debugging.
Captures errors.
Yeah, captures errors as well. Yep.
Okay.
And then more recently, we actually integrated with AWS Config. So AWS Config is an AWS service that lets you basically track configuration changes to specific resources. So for example, you can track the changes for a specific stage. Okay. One use case for that is, we talked about the web application firewall.
Yeah.
And so the web application firewall is actually enabled per stage. So if you had like a company policy that says, hey, all the stages must have a firewall on it, you can actually use AWS Config to monitor whether or not that's true.
Okay.
And if suddenly someone turns off the firewall, you can get an alert as well.
All right.
So
and you won't turn the firewall back on.
No,
it's
let you know.
Monitoring and let you. Okay, so
that's right.
Okay, very cool. All right.
And CloudTrail, works across all AWS services. It basically provides the compliance and auditing story for all the changes that are happening in your AWS account. So, for example, if you want to see, who is creating new APIs, who is changing some configuration, you can do that all through CloudTrail.
CloudTrail, as a developer, is a great tool. It has saved me many times getting to go in and say, no, I'm not the one that deleted all that architecture.
Oh yeah.
It's great to have that audit trail to say, here's what happened, here's who made that call, and here's how we can remediate that. So very cool. All right, so metrics and monitoring. What about logging?
Logging, very similarly, we integrate with CloudWatch logs to offer logging. We offer two types, execution logs. This is really great for debugging, troubleshooting issues. You can specify what logging level you want, whether that's error or info, and you can also opt in for full request response. And because this does log all the requests coming in and out, it can actually get quite big. So I would suggest, turning this on and making sure that just keeping an eye out for the storage size that might be taking up. And then we have access logs. You can customize the log format, but we also have templates for pushing these logs in the common log format, which is basically the same format used by Apache and other web servers, right? So if you have any existing reporting or analytics set up based on those log formats, you can just push the same logs there. So yeah, you can export the logs for custom analytics and reporting.
Awesome. Okay. So if I wanted to get like the standard, hey, who's hit and what IP are they from, that would be here.
Yeah, that would be the access log, and you even use the common log format for that. Yes.
Alrighty, and I can store that in S3 and use Athena or Select or something to.
Yeah, exactly.
Okay. Very powerful. All right, I want to stop here at the moment as we have about 9 minutes. We've got a few more features we're going to cover, but are there any questions that we have that we need to jump into? Do you see any? And I'll let you look through those, and I'm gonna talk about the developer portal in a moment. If you see any questions we need to answer.
Yeah, looks like our moderators are doing their
Excellent.
job. They're
All right.
responding to all the questions.
Thumbs
so
up
we're
to
good.
you guys. All right. So the next feature we're going to talk about is developer portal. This is a very cool feature. The idea here is, one of the things. Hey, I've got this API and I want to monetize it, or I want to make it available to people publicly, or whatever. How do I manage it? How do I offer them keys, different things like that? I don't want to get a call in the middle of the night all the time. Hey, I need an access key.
Yeah.
Things like that. I would have them call you, and so
I'll forward it back to you.
there we go. All right. So the idea behind developer portal is this is something that you can launch from the service application repository.
Yes.
Yeah.
Or even in GitHub and SAM.
That's
we
right.
took an open development model for this.
And so what you're able to do is you're able to launch this up as an application, and it provides some of the new things are APIs search and API discovery, API registration and key generation. So what someone can do is they can come out, they can register for a key, generate the key, and then they have that. And they can also, through the API monitoring and usage, they can tell, hey, here's how much I'm using Alan's API. Here's how much I'm using Eric's API. Mine will probably be. But you can use API documentation. So built into API Gateway is the ability to document, right?
Yep, that's right.
So at the method, at the resource, things like that. And so this API documentation is available through the developer portal. API testing. Hey, I want to test this, make sure I get back the right stuff before I start using it with my customers. And then the SDK generation. Generator or generation. So this is what you were talking about earlier.
Yeah.
So if I build an API and I want to and I need an interface for it, I can generate this SDK right here, right?
That's right, directly from the developer portal. The one I was mentioning earlier, you can also generate in the stages tab of your API.
Okay.
Yep.
And so it's going to have all the libraries and stuff that I need to execute that at the client, right?
That's right.
Okay, excellent, as a package. Very cool.
Yeah, and more recently, we actually, I think just a couple of weeks ago, we pushed out an update for the developer portal that also added some usability improvements. For example, being able to have a feedback channel from your customers to the admins of the dev portal.
Right.
And SDK generation was part of that release. So actually, your slides are really up to date.
I don't want to brag, but there it is. Okay. All right. So the next thing we're going to talk about resource policies, and so the idea behind a resource policy, and this isn't just an API gateway thing, is it?
It's across all, or actually a majority of AWS services. I'm not sure about all.
Yeah, exactly, the majority. So the idea here is I can attach to the resource a policy. That's instead of me saying, hey, I attach to Alan a policy and says what he can get, I can attach to the resource a policy and say this is who can get to me and this is who cannot. And this is another example where you can do things like, it's great for like AWS identity and access. Hey, this particular role from this account can access this resource. Or this is another area where you could do the IP address. If I had to choose between a WAF and a resource policy. I'd probably go the WAF on that. But it's another way you could do that. Where look, I'm just gonna say only this IP address or range can get to that.
Yeah.
So
Good call on the WAF. Yeah.
yeah,
Definitely.
exactly. So along with resource policies and access, another cool thing that we do. And if you could explain is how, let's say I'm an EC2 instance sitting behind the API gateway. How do I know it's the API gateway getting to me?
Yeah, so we have this cool feature called client certificates. So what that is basically it allows your backend, in this case, an EC2 instance, to verify that request is coming from API gateway. So what you need to do is basically generate a certificate in API gateway, and then copy that public key into your EC2, and then you can use that public key to verify that the request is indeed coming from API gateway. We have documentation on we actually even have a code snippet on what your
Nice.
EC2 needs to do.
Nice.
So you can see our documentation on
Pretty
that.
straightforward then.
Yeah, pretty
So
straightforward.
just
Very
API
easy.
call, a couple API calls to validate, something
Yeah.
like that. Okay, alrighty. I just
Well, not
totally
even API call.
minimalized it,
You
yeah.
just need to look at the cert.
Right. Okay.
Yeah,
Evaluate
and the
the
key.
certification.
That's
okay.
right.
Gotcha. Alrighty. Okay. So here's one kind of towards the end that I'm gonna spend a little time on, and this is a big one. Custom domains. Now, at first glance, you might just go, yeah, okay. Custom domains are great because I can call it my own name. I want, ericscutepuppies.com or mydomain.com, something like that.
Yeah.
Rather than 12345.execute.api, the long name. But there's a little more to it than that. There's three things that are important here. Well, number one, it supports REST and WebSocket APIs. So you're able to say, let's say, ericscutepuppies.com, that's my website. api.ericscutepuppies.com is my API. So I'm able to, keep those close. Maybe it's been a long time since I've done any SEO, but maybe that helps SEO, that kind of stuff. The second thing is, when you do this and using API Gateway, your certifications, your SSL certs can be offloaded. We talked about this earlier about having a central point of management. And this is one of those things that come in really handy. With being able to offload your SSL certs to your API Gateway, you don't have to, let's say you have 300 EC2 instances behind it or Lambdas or whatever. You don't have to install those at the server level. You don't have to install them into the EC2 instances, which is kind of how I had to used to do it back in the day before we offloaded to load balancers and things like that. The third thing, and really kind of one of the primary things, is base path mapping. Okay, and what this allows is that you can support multiple domains through this. So if I didn't have this API-1 at the end, then I could only route to one place, and that's wherever mydomain.com went to. But with the base path mapping, I can say API-1 will always go here. API-2 will always go here. API-3. So I can put multiple APIs behind one custom domain. So a lot of flexibility there. One of the this is a very actively used part of the service.
Yeah, definitely. And also one more scenario is that we also see customers use custom domains as a level of abstraction. So because the URL that Eric has crossed out there's actually that 1, 2, 3, 4, 5 part is actually a GUID. You were creating new APIs that actually changes dynamically, right?
Yep.
So every new API has a different address. So if you put a custom domain in front of it, that's a static address that you control and
Don't have to call your clients again.
Yeah, exactly.
Good point. Okay. So then next thing, and this is the last feature we're going to talk about here, is the export and import through Swagger and OpenAPI 3. Now, you got to clear this up for me, okay? Swagger and OpenAPI, are they the same thing? Are they not?
They're typically the same thing now, right? So
Okay.
Swagger was the company that defined that first definition, and when they released Swagger 2, they actually donated that to the OpenAPI consortium, and then when they released the OpenAPI 3 spec, they just named it OpenAPI because it's donated to them.
Okay.
So when you typically hear these two terms, Swagger typically still refers to the V2 version, OpenAPI is the V3 version.
Okay.
Although OpenAPI V2 and V3,
they're pretty similar?
yeah,
Okay.
not similar. I meant Swagger and OpenAPI 2
Oh,
are
okay,
similar.
gotcha.
Yeah.
Okay, all right. Good. Thanks for clearing that up because that's kind of confusing. Okay. So Swagger is OpenAPI 3 minus or up to 2,
Yes.
right? Okay. Good to know. There you go. So the cool thing about this is with API Gateway, I can export to OpenAPI 3. I can export to Swagger, OpenAPI 2.
Yep.
And I can import from both of those. I can also use it as a conversion tool. I can import Swagger and export OpenAPI 3. So there's that kind of power there. And then I can add in Postman extensions, API gateway extensions, and then it can be done in JSON and YAML. And so there's, again, a lot of power in translation there. So we're going to go ahead, and I know we've been answering questions there, and we're out of time. So I'm going to tell you about our next series. Our next session coming up is on April 23rd. It's at 1 p.m., same time, same place. It's called No Rest for the Weary, and this is where we get hands-on. I really encourage you to come check this out. George Mao is going to be joining me. He's one of our senior serverless specialists, solutions architect, and we're going to start building an application and show how these work. Again, I would encourage you to watch the Building Happy Little APIs. It will bring you peace. It will bring you harmony and all those things. And with that, guys, we really appreciate your time. Twitch, we appreciate you having us. Thank you.
Thank you. Are we still here?
There it is.